Introduction to Building Codes. Bangladesh National Building Code 2020. This code is referred as BNBC 2020. Part 8 Building Services. Chapter 5 Water Supply. Part 1 presentation is based upon water supply. The description of this course is as follows. This presentation is designed to familiarize and assist code officials in locating, describing, and applying the applicable code requirements for water supply requirements. Overview. Internationally, code officials recognize the need for a modern, up-to-date plumbing code that addresses the design and installation of plumbing systems through requirements emphasizing performance. This presentation will cover key topics of the following areas: purpose and scope, terminology, permits, license requirements, water supply requirements, water sources and quality, water supply system and the water service pipe materials, excavation of trenches and refilling, inspection, testing, and completion certificate, and individual water supply system. This is a complete overview of the water supply system. Our seminar goal today is, the goal of the training is for you to learn and apply key code requirements contained in Chapter 5, Water Supply, to enhance your performance while inspecting these systems. It's so important to understand code requirements. We take code requirements based upon applications as inspectors. We need to completely understand the intent of the code as it applies to certain areas within the water supply system. We will be going through many examples of code requirements and applications to reinforce that part of this seminar goal. Additionally, this training will also provide participants with specific code requirements with examples related to design, installation, and inspection of water supply systems to further enhance your knowledge. Upon completion of this seminar, you will be better able to locate general topics in Chapter 5 Water Supply, locate applicable codes and standards for specific situations, apply code requirements to real-world situations, explain the intent behind a given code requirement, and use good judgment to identify certain systems and related components as compliant or non-compliant. Additionally, the objectives for you are to help you navigate through this code, understand certain requirements, understand when references are made to different sections of the code, or possibly an appendix as well for additional information. Some general information regarding water supply. Plumbing fixtures, devices, and appliances that require the use of water for proper operation are required to be connected to the water distribution system of the structure. which is then connected to an approved source of water, either a public or private source. Generally, approved water sources may be by means of public water utility. However, where potable public water supply is not available, individual sources of potable water may be used when approved. This is typical if there is no public water in the area of a proposed building. You would submit to the authority plans, specifications based upon the requirements set forth in this particular code for approval of that particular private water supply. Quite often, an individual source of potable water is a private or community well. It is common for both public and private or independent potable water sources to be regulated by agencies or departments outside of the typical building department. So as a participant in this seminar, we should be aware of who these agencies are that regulate different parts of the water system, from the water main to the water service pipe, and then into the building and the building's distribution system. Chapter 5, Section 5.1 gives us requirements regarding purpose and scope. The purpose of this chapter of the code is to provide minimum standards for the design, installation, and maintenance of water supply and distribution system within a building and its premises. So just reading that introduction sentence, you find that there are two different types of systems. The first one is called the water supply system. The second one is called the distribution system. The demarcation between the two can be looked at as the main shutoff valve at the building from the water supply connection that's tied to the main water at the public tap-in. So when we take a look at the water supply, we are looking for the proper design of this system, and it guarantees that the water remains drinkable and is not contaminated by any backflow condition or cross connection. We need the water to be safe and healthy for all of the occupants in the building. Drinkable water is viewed as a precious commodity by everybody, and it must meet minimum quality requirements. We will use this code as a guide to locate certain quality requirements as well. The authority has the responsibility for administering the code to ensure that water supplies to homes and the buildings in which people live and work are designed and installed to provide safe, clean, and healthy drinkable water. Section 5.1.2. The regulations of this chapter also provide guidelines for water requirements for different classes of buildings according to their occupancy classification. Water requirements for daily domestic use of a building shall be assessed on the basis of one or more or a combination of the following. This is where we estimate the water supply usage. The first one is water consumption for domestic purposes in residential buildings, cities, big district towns, areas like that. Socio-economic group, type of building, source, and other facilities must be taken into consideration with respect to the demand of water that must be supplied to these facilities. Water requirement for domestic purposes in residential buildings. This is in village areas and small communities. A scaled down version of what we found in the residential buildings up above for cities and big district towns. So based upon the use, location, and size of the residential buildings, there are two different methods here to figure the demand of this system. Domestic water requirements for various and other occupancies and facility groups. Now, section 5.1.3 gives us the requirement for the provisions stated herein do not cover the requirements of water supply for industrial plants and processes, municipal uses, street washing, street hydrant, etc. So again, the water requirements are not covered for those specific operations and functions and buildings as well. Chapter 5, Section 5.2, Terminology. This section is very important that we understand the language in the code that we need to follow for water supply requirements. Many terms and sets of words have a very specific meaning based upon the code section requirements and tables listed in this particular code. So this section provides an alphabetical list of the terms used in and applicable in this chapter of the code. In case of any conflict or contradiction between a definition given in this section and that in Part 1, the meaning provided in this section shall govern for interpretation of the provisions of this chapter. Therefore, the specific words in this particular area of the code are specific and take precedence over Part 1. As you know, we will be talking about water supply systems, and the language indicated in this particular chapter will apply specifically. A code provision could be misinterpreted if the definition of a term as used in the context of the code is not understood. We must thoroughly understand the language. The following slides will provide key definitions that will assist the code user to properly understand certain terminology related to this chapter. Codes, by their very nature, are technical documents. As such, literally every word, term, and punctuation mark can add to or change the meaning of the intended result. This chapter contains several terms that are important to understand the provisions of this code. Definitions are found both in this chapter and throughout the code. Let's look at some key terminology. The first term that we're going to look at is accessible. And the term accessible has some very specific language. It means when applied to a fixture, appliance, or equipment shall mean having access thereto, but which may require the removal of an access panel or similar obstruction. Now, if we had a valve, let's say, behind a wall, we could use an access panel on the surface of the wall to gain access to the valve behind the wall. That would be an accessible valve. Continuing the definition, readily accessible shall mean direct access without the necessity of removing any panel, door, or similar obstruction. As seen in the picture below, we have two water storage tanks that are readily accessible. They are located in a room that is readily accessible to maintenance personnel, people to operate the controls. You can approach each one of these water storage tanks, and they are defined as readily accessible. As such, they do not meet the accessible meaning because there are not any panels or doors to go through or to remove to gain access to these particular water storage tanks. So that's how we apply the definition accordingly. Available head is defined as the head of water available at the point of consideration due to mains pressure or storage tank or any other source of pressure. Backflow is defined as the flow of water or other liquids, mixtures, or substances into the distribution pipes of a potable water supply from any source other than its intended use. This is something that we need to avoid. We need to avoid any other fluids, mixtures, other than potable water to gain access into the piping system. That's why we have backflow preventers. And by definition, a backflow preventer is a device or means to prevent backflow. As seen below, consider a boiler. A boiler has a connection to the potable water supply called makeup water. As can be seen in the graphic here, we have a backflow preventer with an intermediate atmospheric vent. Now, generally, there are three distinct classes of backflow equipment. There are assemblies, devices, and other means or methods. This class distinction clarifies that an assembly is field testable. A device is not testable in the field, and a mean or method is observable for its adequacy to protect the potable water supply from backflow. As can be seen here, this is a backflow preventer with check valves. As you can see, it's an intermediate atmospheric type vent designed to prevent backflow going from the boiler back into the potable water source. Based upon the pressure differentials between the check valves, lower pressures in the potable connection to the backflow will foul or translate the water through the intermediate atmospheric vent at the bottom of the backflow preventer, thus not allowing the water to migrate back into the potable water supply. This is one means of how we protect the potable water supply from backflow. Building supply. The water supply pipe carrying potable water from the water meter or other source of water supply to a building or other point of use or distribution on the lot. That is defined properly as building supply. Plumbing system is very specific. It is defined as a system of potable water supply and distribution pipes, along with plumbing fixtures and traps, soil waste and vent pipes, and sanitary and storm sewers, and building drains, including their respective connections, devices, and appurtenances within a building or premises. So as can be seen by the definition of plumbing system, it essentially indicates the entire parts and different systems that we utilize in our building, from not only water supply and distribution piping to the sanitary and storm drainage system as well. The last definition is water supply system in this particular slide. This is a system consisting of building supply pipe, water distribution pipes, and necessary connecting pipes, fittings, control valves, and all appurtenances carrying or supplying potable water in or adjacent to the building or premises. Now, in the graphic indicated here, we see three distinct systems. The first system that we will talk about is called the water supply system. As can be seen, we see where the water main is located outside of the building. It is labeled water main. From the water main, there is a tap off of the water main that supplies water through a pipe to a valve. This is usually a utility shutoff valve or a utility stop valve located at the street for a public water main. From that point, we run piping, the water service pipe, into the building, and once it enters into the building, we locate and install another valve. This could be termed as a control valve. This can be termed as a main shutoff valve. This will completely shut off the water to the entire building from within the building. From that point, it becomes the water distribution piping system. And this is where we start to feed or supply the fixtures within the building. We supply the sinks, we supply the water closets, we supply the cooking fixtures that utilize potable water, things of that order. That is the water supply and distribution system. As seen here by definition, plumbing system, we also have the public sewer or the main sewer. That is connected by means of a tap from the building coming into the public sewer. The building sewer is located outside of the building. Once it gets into the building, it becomes the building drainage system. As can be seen in the graphic here, by gravity, all of the sanitary drainage is located at the lowest point and discharges out of the building through the building sewer into the main public sewer. And the piping within the building is connected, of course, to fixtures that discharge waste and sanitary drainage downward. The last system that we look at is to the right on the graphic. This is our storm sewer system. And as we can see here on the right-hand side, outside of the building, is our building storm sewer. this is a point that collects the water, in this application, from the roof drain. We collect the water, rainwater, from the roof through roof drains into vertical pipes that we call conductors that then connect into the building storm drainage system. As can be seen here, there is also a lower level sump that is below the finished floor in the basement to collect any residual subsoil water and drain it by gravity into the sump. There is a submersible pump within the sump here, and based upon the elevation of water within the sump, a float type system engages the pump and therefore lifts the water up into the building storm drain and allows it to drain by gravity completely outside of the building. This is what we call the plumbing system by definition. Horizontal pipe is any pipe or fitting which is installed in a horizontal position or which makes an angle less than 45 degrees with the horizontal. This is important to us to understand once we get into the drainage part of the plumbing system. Vertical pipe is any pipe which is installed in a vertical position or which makes an angle of not more than 45 degrees with the vertical. As can be seen here in the graphic, we point out horizontal branch or horizontal branch drain. As can be seen here, this is properly called a horizontal pipe due to the fact that it makes an angle less than 45 degrees with the horizontal. In the middle, we have a pipe called a water riser. That is a vertical pipe, and it fits the definition. This pipe is, in fact, a vertical pipe due to the fact that it makes an angle of not more than 45 degrees with the vertical. Service pipe is specifically defined as the pipe that runs between the distribution main in the street and the riser. In case of multi-storied buildings or the water meter, in the case of an individual house, and is subject to water pressure from such main. As can be seen in the graphic, water service or the water service pipe is located accordingly. Section 5.3 gives us the requirements regarding permit for water connection. Section 5.3.1, requirement of permit, indicates that no water supply system shall be installed in a new building until a permit for such work has been issued by the authority. So it gives us in that first sentence a directive that no construction of any water supply system shall begin until there is a permit that has been issued by the authority. The addition or alteration of existing water supply facilities in a building shall also require a permit for their installation. It goes on further to indicate that if you are adding on to the water supply system or even altering an existing water supply, there is a requirement for a permit, and it must be issued by the authority. Section 5.3.2, application for permit. obtaining public supply connection. Now, the application for a permit for water supply system shall be made in writing by the licensed plumber and the owner or his appointed person or persons or agent on a prescribed form. The reference here is given to us as Appendix M for an example of this particular form. Design drawings, calculations, and other submittal documents must accompany the permit application and be of sufficient detail and clarity to verify compliance with the code. So not only the application must be made out and submitted by the licensed plumber and the owner, also design drawings must accompany the application as well. Appendix M contains a prescribed form regarding information required to construct the water supply and distribution system. We have the application format for permit to construct water supply and distribution system. As you see here, this is an application that serves a dual purpose. It is for both the water supply and distribution system. And some of the information that is needed on the application is as follows. Item number 1, name of the applicant, either the owner of holdings, father's name, mother's name. Number 2, the address, location of plot, holdings, specific information like ward number, road number, house number, boundary description. So there is a clear-cut understanding of exactly where the construction of the water supply and or distribution system is being installed. Item 3, the description of holdings, buildings and premises, type of building and structure. There is also a requirement in 3B for the occupancy classification, and in 3C, the number of floors and room numbers. 4A gives us a line item for the total population. 4B, type of connection, residential, commercial, or industrial. 4C, total water requirement, and indicated here, calculation sheet should be attached. Now, this is important here, that the demand of the system and the calculations be submitted with this application. The authority will review the proposed water requirement and the calculations utilized to prepare that particular water requirement demand. 4D, size of water connection, diameter of pipe, and the water connection size is required to be listed here. Number 5, underground water reservoir capacity, where required. This is if you have a private water supply system or maybe assisting for additional water storage. Number 6, certificate of bill payers. Number 7, this application is accompanied by all required plans, drawing of buildings, design calculations of water requirement in accordance with sections 5.3.2 and 5.3.3 of the Bangladesh National Building Code. And finally, as can be seen, the signature of the licensed plumber is required, along with the name and address of the licensed plumber, The signature of the owner or his or her designated person or agent is required as well, and the name and address information accordingly. So, as can be seen here, Appendix M contains a pretty detailed application format for permit to construct water supply and distribution systems. Section 5.3.2, Application for Permit, Obtaining Public Water Supply Connection. The application shall accompany building drawings showing the water supply system with the following details. As stated before, we went over the application specifically. Now we need to make sure that we have the details as far as the building drawing showing the water supply system. Item A requires site plans showing the location of the water main. Item B, typical floor plans and elevations of the building with the position of different plumbing fixtures and piping. This needs to be indicated on the construction documents, drawings. Item C, material sizes and gradients of the proposed interconnecting piping system. We will take a closer look at this coming up. Item D, pipes, if any, conveying non-potable water for flushing water closets and urinals shall be marked by distinctive, durable yellow color. This is denoted on the drawings for this non-potable water. Item E, design calculations of water requirement indicating considerations of per capita water requirement and population. A detailed review of plans and specifications is necessary to verify that the design complies with the code, thereby avoiding costly modifications during the course of installation. Jurisdictional policies differ in the handling of incomplete or incorrect plans. An example of gradient increases and pressure results. Consider the water main at the street elevation. From the water main, the tap from the water main supplies water to the point of delivery at a higher elevation than the water main itself. We need to understand how elevation affects pressure. A simple equation called pressure difference is calculated by the following. P equals H times 9.81 kPa, where P is the water pressure in kilopascals, H is the head, which is the elevation difference in meters, and 9.81 kilopascal is the pressure resulting from 1 meter head of water under the force of gravity. Now, as seen here, static pressure, we have an elevation difference of 5 meters. 5 meters. So the static pressure loss is calculated according to our example. The example given in the box located at the right side of the slide indicates calculated loss of pressure. This will be negative due to elevation difference and available static pressure at point of delivery. So, the pressure at the water main, indicated as P sub M, is 690 kilopascals. The elevation difference is 5 meters. As you can see, the elevation difference is, of course, higher at the point of delivery than the water main itself. So the elevation difference is 5 meters. P sub L then equals negative H times 9.81. We understand by increasing in elevation, we will have a pressure loss. Therefore, the convention in an upward direction, increasing elevation, is negative. So we use a negative symbol before the H, which is our head. We plug in the necessary variables. Negative 5 times 9.81 results in a pressure loss of 49 kilopascals. The available static pressure at the point of delivery is as follows. The pressure at the point of delivery equals the pressure at the main plus the pressure loss that we just calculated. The pressure at the main is 690 kilopascals, and we add that to the pressure loss of 49 kilopascals. The resultant static pressure at the point of delivery is then 641 kilopascals. Now, designers must also consider friction losses in the piping, fittings, and other equipment as well as the total design for pressure loss in the system. An example of gradient decreases and the resulting pressure losses. As can be seen in this graphic, the water main is at a higher elevation relative to the point of delivery at the building. The pressure difference equation is the same. The only difference here is our convention. As indicated in our example, calculate gain of pressure. It's going to be positive due to the fact that we have gravity and we have a lower elevation at the point of delivery below the water main. The pressure at the water main, again, is 690 kilopascals. The elevation difference is 5 meters. The pressure indicated here is H times 9.81. Simply understanding our elevation difference, we realize that it is 5 meters times 9.81, which equates to our pressure gain of 49 kilopascals. So the available static pressure now at the point of delivery is the following summation. The pressure at the water main, 690 kilopascals, is added to the pressure gain now of 49 kilopascals due to the elevation difference. At the point of delivery, we have a resulting pressure of 739 kilopascals. And again, noting designers must also consider other friction losses in piping, fittings, and other equipment as well. Section 5.4.1 gives us a licensing requirement. Plumbing work shall be executed only by a licensed plumber under the control of the authority and shall be responsible to carry out all lawful directions given by the authority. No individual, partnership, corporation, or firm shall engage in the business of installation, repair, or alteration of water supply system without obtaining a license from the authority. This section mandates that any plumbing work must only be executed by a qualified plumber. Licensure of qualified plumbers is a requirement in this section for any installation, any repair, or any alteration of water supply systems. And the license comes from the authority. Section 5.4.2 gives us the examination and the certification requirements for plumbers. The authority shall establish a plumber's selection and examination board. The board will determine A, the requirements of obtaining a license, minimum academic qualification, as an example, minimum practical, vocational, or other training needs to be considered, minimum years of experience, as well as total volume of work done. And B, finally, establish standards and procedures for examination of applicants for license. This is important because the authority establishes the examination board, and the board will put together the requirements for obtaining the license as indicated in A, as well as B. The authority will issue the license to such applicants who meet the qualifications thereof and successfully pass the examination conducted by the board. So not only do you need qualifications in the plumbing trade, but you must pass an examination. In order to qualify as a licensed plumber, the authority establishes the examination board in a selection process. Qualified individuals must meet academic, vocational, and experience requirements. Additionally, they must complete and pass an examination. This process ensures the safety of people by allowing only qualified people to install, repair, and alter water supply systems. In section 5.5.1, buildings equipped with plumbing fixtures and used for human occupancy or habitation shall be provided with the supply of cold potable water in the amounts specified in sections 5.5.2 to 5.5.4 and at the pressure specified in sections 5.10.4.2 and 5.10.4.3. Those sections indicate the water distribution system. The importance of this particular section with respect to the water supply system is that only potable water shall be accessible to the plumbing fixtures supplying water for drinking, bathing, and culinary use, and for the processing of food. Additionally, 5.6 provides information for estimating total water supply demand using various methods. So the code user is directed to section 5.6 for specific information on estimating the total water demand. Section 5.5.1.2 gives us a requirement for non-potable water that may be used for flushing water closets and urinals, provided such water shall not be accessible for drinking or such other purposes. As we saw before in a previous code section, the indication of the piping must be yellow in color to demarcate and help people within the building understand that this is a non-potable system. Indicated in the graphic is what we have called gray water. Gray water. This is where we take water from a lavatory that is being drained down the fixture drain and directed to a storage tank. The gray water storage tank and treatment is taken care of at that elevation. Normally we would have a pumping system to pressurize the non-potable water feeding to the water closets. So we can reuse the water that has already been used at the lavatory and term that as gray water and pump it through after it's been treated to a non-potable piping system. In this case, it goes from the gray water storage tank to the water closet, and it is used for flushing of the water closets. On-site potable water reuse systems collect wastewater from bathing and laundry drainage as well, and often referred to as light gray water. Section 5.7.1 Sources of Water. The origin of all sources of water is rainfall. Water can be collected as it falls as rain before it reaches the ground, or as surface water when it flows over the ground, or is pooled in lakes or ponds, or as groundwater when it percolates into the ground and flows or collects as groundwater, or from the sea into which it finally flows. Surface waters are physically and microbially contaminated and cannot be used without treatment. On the other hand, groundwater sources are chemically contaminated and treatment may be necessary in many cases. So this requirement, sources of water, gives us an indication of where the water comes from, possible contamination, and treatments that may be necessary in certain cases. We move to the next section, which is section 5.7.2, quality of water. The quality of water to be used for drinking shall be maintained using WHO Water Safety Plan and shall comply with the Environment Conservation Rules, ECR 1997, and WHO Guideline 2004 values as presented in Appendix P. For purposes other than drinking, water, if supplied separately, shall be safe from bacteriological contamination so as to ensure that there is no danger to the health of the users due to such contaminations. Appendix P gives us water sources and quality for domestic purposes. As can be seen with respect to this particular guide or chart, it is titled Table 8.P.1, Water Quality Standards. In the very first column, water quality parameters, items 1 through 30, gives us, in terms of values, the unit value in column number 2. Column number 3 gives us the WHO guideline values. And finally, in the last column, gives us information regarding environmental conservation rules. As can be seen here, item number 1, pH value, indicates WHO guidelines, WHO guidelines, between 6.5 and 8.5, and the resulting environmental conservation rules indicate the same values. Turbidity is another concern with respect to water. The WHO guidelines values are 5, whereas the environmental conservation rules are 10. So with respect to the water quality, the designer, the authority would come together and verify that the water has been treated to a certain standard, as indicated here in Appendix P. We can also use water and reclaim the water. Section 5.7.3 allows wastewater reclamation. Treated sewage or other wastewater of the community may be utilized for non-domestic purposes, such as water for cooling, flushing, lawns, parks, firefighting, and for certain industrial purposes, after giving the necessary treatment to suit the nature of the use. Very important statement there. Treatment to suit the nature of the use. Many cases, the water must be treated due to possible contaminants in the water. It must be filtered to remove certain particulate matter as well. This supply system shall be allowed in residences only if proper provision is made to avoid cross-connection of treated wastewater with domestic water supply system. Whenever a building is used after long intervals, the water quality of the stored water must be checked so as to ensure the water is safe for the use per water quality requirements specified in this code. As seen below, we have a commercial or an industrial application here of utilizing reclaimed water, storage tanks for firefighting operations. This is a series of water storage tanks utilized for automatic sprinkler systems in commercial and industrial type buildings. In other words, we can utilize water that has already been used. We can reclaim that water, treat it, filter it for this particular application. It's a great way of conserving water. Section 5.8, Water Supply System. The main requirement here is each floor or unit within the water supply system shall be provided with a control valve in addition to the main control valve at the entrance of the system. One of the following public water supply systems shall be adopted for distributing water to the plumbing fixtures within the building. We are directed to see Appendix O. In the graphic below, we see the water service pipe coming from the city water main. We have a main water shutoff valve, and as the water piping connects the first floor and the second floor levels, we have separate control valves. So this is an example of a water supply system provided with a main control valve and separate floor control valves to control the water flow at each floor elevation. As directed in Section 5.8, Appendix O gives us requirements for sizing of cold water supply and distribution piping. The water distribution within the building may be an upfeed or downfeed system. The design principles are the same for both the systems. The principal difference in calculation procedure is that in the upfeed system, the difference in elevation between the fixtures and the water supply main exerts pressure that supplies water into the fixtures. But the downfeed system, the difference in elevation between the fixtures and the roof storage tank provides pressure to overcome the pipe friction. The following are the recommended pipe sizing procedures. There are several here. The first one, 0.1, the sketch of the main lines, risers, and branches serving different fixtures will have to be drawn. That's first and foremost. It is a requirement. 0.2, determine the number and types of fixtures that will be required on the basis of Table 8.6.1 in Chapter 6. We will locate the fixtures, we will indicate how many fixtures, and this is a requirement based upon Table 8.6.1 in Chapter 6. 0.3, the demand weight of different fixture units may be computed in terms of water supply fixture units, or we say WSFU, in accordance with Table 8.0.1. We could use in 0.4 the peak demand load, or maximum probable flow in liter per minute, may be estimated with the data obtained in section 0.3 using figure 8.0.1, or on the basis of the number of occupants according to their occupancy classification specified in Table 8.5.1. In item 0.5, the equivalent length of the main lines, risers, and branches will be determined. The equivalent length of different fittings may be estimated on the basis of the data presented in the tables as follows. Table 8.0.2a, Table 8.0.2b, and Table 8.0.2c, or from manufacturer's specification. The total equivalent length is the sum of the equivalent lengths of all pipes and fittings. We need this to determine the pressure losses, not only in the pipe, but also the pipe fittings. 0.6. The pressure loss through water meter may be determined on the basis of their operating characteristics, as shown in figure 8.0.6, referencing the disc type water meter. The data for other types of water meters may be obtained from the manufacturer. Again, this water meter equipment, we call it, definitely has a pressure drop, and we need to know what the pressure drop is, because this is a loss in pressure that needs to be accounted for when we are designing our cold water supply piping system. Continuing on, 0.7, the minimum pressure required at different fixtures to produce adequate flow may be estimated on the basis of the type of fixtures or minimum size of supply pipe in accordance with Table 8.5.6. We have 0.8, which gives us an equation. the average pressure drop in kilopascals per meter of equivalent pipe length that may be computed as follows. The equation gives us where F sub P is the average available pressure loss in kilopascals per meter of equivalent length of pipe, equates to the quantity of pressure in the water main, or 0 for overhead gravity storage tanks. We look at the height in meters of the highest fixture above the water main, or difference in meters in elevation between the storage tank and the fixture under consideration. Again, we call this the head, or the total height of difference. F is the pressure loss in kilopascals through water meter or such other fittings, plus pressure required to produce adequate flow through the most remote fixture in upfeed system or the fixture under consideration in a downfeed type system. Once we have determined that quantity, we divide by L, which is our equivalent length of pipe in meters. And as you can see, the convention of signs is positive for downfeed systems and negative for upfeed systems. As we saw before with differences in gradients when we were talking about the water supply, any upward elevation from the point of supply to the point of delivery results in a pressure loss. Case in point, we see a negative sign for upfeed type systems. The following are the recommended pipe sizing procedures. In 0.7, the table was indicated as table 8.5.6. This table gives us water supply system design requirements. In this table, the fixtures are indicated in the first column. We have fixtures that are called bathroom group, bathtub, clothes washers, kitchen sink, laundry tray, service sink, and different types of water closets as indicated in the first column. It identifies the fixture that needs to be designed to be supplied by the water supply system. The second column gives us supply control, whether it is a flush tank, a flushometer valve, a faucet, or a mixing valve, the supply control. The third column gives us the minimum size of the supply pipe in millimeters. As an example, a kitchen sink. A kitchen sink is indicated as the fixture. The supply control is a faucet. The minimum pipe supply must be not less than 13 millimeters. The fourth column gives us the required flow pressure in kPa. For the kitchen sink, having a minimum pipe diameter of 13 millimeters, we are required to have a required flow pressure of 55 kilopascals. The very last column, required flow rate in liters per minute. For the kitchen sink, our example, very last column, the required minimum flow rate is 9.5 liters per minute. So we can systematically pick the fixture or group of fixtures and obtain minimum pipe sizes, required flow pressures, and required flow rates. As an example, we continue on item 0.9. The pipe size may also be estimated from figures. Figure 8.0.5 to 8.0.10 for different types of piping materials on the basis of expected rate of flow determined in section 0.4 and the average pressure available for friction loss, F sub P, in section 0.8. Now, this particular figure that you're looking here is a logarithmic chart, and it gives us on the x-axis, or the lower level, the flow in liter per minute. On the y-axis, or the vertical axis, it gives us friction loss in kPa. This particular table figure is friction loss through taps and T's. So as an example, find the friction loss in kPa for a 19 millimeter T fitting with a flow of 50 liters per minute. We can simply go to the horizontal axis on the logarithmic scale. As can be seen, it starts at 10 liters per minute, so we move over to 50 liters per minute. 50 liters per minute, we rise up and intersect with the diagonal curve indicated at 19 millimeters. Once we intersect that curve, we move to the vertical axis and read the friction loss in kilopascals, which in this case, for a 19 millimeter T with a flow rate of 50 liters per minute, we have the friction loss of 8 kilopascals. And the designer would continue to do this for different types of fittings throughout the water supply system and determine the total friction loss by calculating that along with the friction loss in the pipe as well. Section 5.8.1, direct connection to the water main. For continuous water supply system with sufficient pressure to feed all plumbing fixtures during peak demand period, the direct connection of water distribution system to the water mains may be adopted. However, direct pumping from the public water main should strictly be prohibited. So this section provides specific information for direct water supply connections to the water mains. It requires that the water main must be able to supply adequate flow and pressure capacity for the peak demand of the building. In other words, it needs to be calculated as such for the building and verified that the water main can handle the load applied. Additionally, direct pumping from the water main is specifically prohibited. Now we can pump after the water main when we get into the building or up to the building, but we are not allowed to direct pump from the public water main. As an example, we have a public water main shown here. The water main must be able to supply the adequate flow and pressure capacity for the peak demand of the building. So this is indicated in the previous sections. We need to make sure as the authority that the system water main has enough capacity to provide adequate flow and pressure at the peak demand of the particular building. From the tap off of the water main, there is a stop valve, normally located in close proximity to the water main tap. This allows the utility or the authority to shut off the water supply to the building for maintenance and other reasons thereof. This is called a direct connection to the water main. Section 5.8.2 indicates a system of incorporating balancing roof tank and direct water main connection. So for continuous water supply system, let's say with inadequate pressure, only during peak demand hour, or for intermittent water supply with sufficient pressure to feed the balance tank, a balancing roof tank shall be required to feed plumbing fixtures within the building. The connection to the balancing roof tank from the water main or from ground tank or from individual water sources shall be through a non-return valve. As seen in the graphic, the water main is indicated underground. The tap to the water main is made and piped to a non-return valve. As seen here, we go horizontally into an underground reservoir tank. Additionally, there appears to be enough pressure to provide a direct supply to the outlet of the pump and carry the water up dynamically under pressure to the overhead storage tank. And this is a system incorporating a balancing roof tank. From the roof tank, as can be seen here, we have a downfeed system. On the top level, we have a downfeed branch that comes from the tank and feeds a toilet and kitchen area on the uppermost floor. As we come down, we have downfeed pipes that feed successive floors downward in elevation. Section 5.8.3 gives us a requirement for a system incorporating a ground tank. As seen in the graphic, we have a water main with a non-reversing valve feeding directly into an underground reservoir or storage tank. For water supply systems with inadequate pressure to feed plumbing fixtures or balancing roof tank, the building premises shall have a ground or underground tank to store water. The water from the ground tank shall be boosted up to the roof tank to feed plumbing fixtures. This is done through a pump, as seen in the graphic, where the suction line of the pump draws from the underground reservoir, pumps it through the pump from the discharge side of the pump, piped vertically to the overhead storage tank. The connection of the water main to the ground tank shall be through a ball valve system. Installation of booster pump directly into the water main shall not be allowed. In other words, we are allowed to have the pump above the underground reservoir as shown. Since the system cannot ensure protection upon possible contamination, particularly during a flood, disinfection system should be incorporated. Therefore, we need to maintain the potability of the water to prevent contamination in systems like this. And the requirement given to us in section 5.8.3 reinforces that in the very last sentence here. Cleanliness and suitable drinking water is of the utmost importance for public safety and public health. Section 5.13 is the materials section. We have several different types of materials to choose from with respect to water supply systems. The materials and fittings for water supply and distribution pipe and for storage tank shall comply with the standards listed in Part 5 of this code and those specified in this section. By referring to standards, we are guaranteed that the material will be durable and sustainable if specified correctly based upon the testing standards and the end use of the system by designing it according to these principles and standards that are given to us in this code. The materials chosen shall be resistant to corrosion, both inside and outside, or shall be suitably protected against corrosion and free from all toxic and harmful substances. Polyethylene and unplasticized PVC pipe shall not be installed near hot water pipes or near any other heat source, due to the fact that these materials will combust, they will melt, they will deform near high heat sources. All joining of pipes and fitting shall be done in accordance with acceptable standard practices. This is how we connect the pipes, either by welding, brazing, threaded fittings, soldering, different types of joining methods with the associated fittings. Section 5.13.1 gives us specific requirements regarding the water supply service and distribution pipes. They shall conform to the standards that are listed in tables 8.5.9 and 8.5.10. The water supply pipes and tubing used outside of the building or underground shall have a minimum working pressure of 1.1 megapascals at 23 degrees Celsius. So right there is a minimum requirement for the working pressure that water supply pipes used outside of the building or underground must meet. In case of water supply exceeding 1.1 megapascal pressure, the piping material shall have at least a rated working pressure equal to the highest available pressure. This is when we deal with systems at higher pressures than 1.1 megapascals. The hot water distribution piping shall have a minimum pressure of 550 kilopascals at 80 degrees Celsius. Different types, classes of unplasticized PVC pipes are used for both service and internal distribution pipes, as described in Table 8.5.11. However, polyvinyl chloride PVC plastic pipes shall not be used exposed and unprotected as riser or water distribution pipe. Polyethylene or unplasticized PVC pipe shall not be installed near heaters or water heater piping. Lead pipes may be used only for flushing and overflow purposes in a water supply system. This is a very large section here, and it gives us plenty of requirements regarding water supply pipes and tubing, minimum working pressures, as well as the hot water distribution piping once we get into the building, giving us the minimum pressure of that hot water distribution piping, as well as different classes of piping and tubing as well. So again, this section provides the requirements for minimum working pressure, maximum working pressure, and temperature limit regarding water supply service piping. The table that was referred to, Table 8.5.9, Water Supply Service Pipe, is given here as an example. The materials are indicated systematically on the left-hand side of the table. To the right column is our standards. These are our test standards for the materials that have been indicated in the first column. As an example, brass pipe references the test standard ASTM B43. ASTM is the American Society for Testing of Materials, and this particular standard is referenced for brass pipe. As you can see, based upon the material, cast iron water pipe references the standard ASTM D377, and as we go down for the allowable materials for water supply service pipe, when we get down into the PVC plastic pipe, it references 3 different and distinct standards due to different types of PVC plastic pipe. So this table essentially provides acceptable piping materials with the associated standards for water supply service piping. As an example, copper or copper alloy tubing can be seen here in the table as a material. However, there are several standards that are associated with this type or these types of materials used for water supply service pipe. As we break it down, an example indicated below the table is copper tubing. Copper tubing needs to meet the standard ASTM B88. PVC plastic pipe has many associated standards with it. Schedule 40 PVC plastic pipe is the reference standard ASTM D1785. Section 5.14, General Requirement for Pipe Work. In this section, Section 5.14.1, we're going to cover some key sections regarding public water mains. Some of the key sections that we want to share with you are the following principles that shall apply for the mains. Item A, service mains shall be of adequate size to give the required rate of flow. Therefore, the designer, the engineer, must make sure that the service mains are adequate in size to give the required rate of flow that is demanded of them based on proposed buildings, residents, things of that nature. Item G, mains need not be laid at unvarying gradients, but may follow the general contour of the ground. They shall, however, fall continuously towards the washout and rise towards air valves. The gradient shall be such that there shall always be a positive pressure at every point under working conditions. The cover for the main shall be at least 900 millimeter under roadways and 750 millimeters in case of footpaths. This cover shall be maintained from the top of the pipe to the surface of the ground. As indicated, the main shall be located sufficiently away from other service lines like electric and telegraph cables to ensure safety. Separation is of the utmost importance here. Where the mains cannot be located away from such lines, suitable protective measures shall be accorded to the mains. As an example, regarding the mains under a roadway, the cover is indicated here above the main, as seen here, measured from the top of the pipe to the surface of the ground, must be a minimum of 900 millimeters under roadways. And as can be seen here, there is proper bedding underneath the pipe for its continuous length to support the bottom of the pipe as well. Section 5.15, Safe Conveyance and Distribution of Water and Prevention of Backflow. This section gives us some basic principles regarding a wholesome water supply must be provided for drinking and culinary purposes, shall not be liable to contamination from any less satisfactory water. Right there is a requirement that is mandated that wholesome water needs to be supplied for these functions within our buildings. There shall therefore be no cross-connection whatsoever between the distribution system for wholesome water and any pipe or fitting containing unwholesome water. In other words, no cross-connections are permitted, or water liable to contamination, or of uncertain quality, or water which has been used for any other purpose. The provision of reflux or non-return valves or closed and sealed stop valve shall not be constructed as a permissible substitute for complete absence of cross connection. Now, the indication here does not permit the use of reflux or non-return valves to complete any type of cross-connection method. It is not permitted. In other words, you want to maintain that wholesome, potable water maintained throughout the system with no possibility of any cross-connection. B, the design of the pipework shall be such that there is no possibility of backflow towards the source of supply from any cistern or appliance, whether it is by siphonage or otherwise. Again, reflux non-return valves shall not be relied upon to prevent such backflow. Even in backflow situations where we have pressure differentials, where unwholesome water may flow back towards the potable water supply, we will not rely on these valves such as non-return valves. They cannot be relied upon to prevent such backflow. There are particular devices and assemblies to prevent backflow that we will talk about a little bit later. This gives us the general requirements regarding basic principles. Section 5.15.1, Item C, where a supply of less satisfactory water than wholesome water becomes inevitable as an alternative or is required to be mixed with the latter, It shall be delivered only into a cistern and by a pipe or fitting discharging into the air gap at a height above the top edge of the cistern equal to twice its normal bore, its nominal bore, and in no case less than 150 millimeters. It is necessary to maintain a definite air gap in all appliances or traps used in water closets. As an example, in the graphic shown is a water storage tank. We have a supply pipe supplying water to the water storage tank. The nominal bore of this supply pipe is 63 millimeters. So the example given here is, what is the minimum air gap required for a 63 millimeter supply pipe above the top edge of the cistern? We simply put it in the form of an equation as indicated in item C above. We are allowed 2 times the nominal bore. So we take 63 millimeters times 2, and that produces the product of 126 millimeters. That is less than 150 millimeters that is given to us in item C as a minimum air gap. Therefore, the air gap must be at least 150 millimeters from the top edge of the cistern to the supply pipe outlet. A note to the code user: requirements regarding capacity of storage tanks and construction of storage tanks is located in section 5.9. Section 5.16, laying of pipes on site. This particular section gives us requirements regarding excavation, trenches, and refilling. Some key sections that we're going to learn about are given in section 5.16.1. Item A indicates the requirement that the bottoms of the trench excavations shall be so prepared that the barrels of the pipes, when laid, are well bedded for their whole length on a firm surface and are true to line and gradient. B, in the refilling of trenches, the pipes shall be surrounded with fine selected material, well rammed so as to resist subsequent movement of the pipes. This section mandates that the materials become rammed and compacted around the pipe to actually secure the pipe in place to prevent movement of the piping system. Item C, no stone shall be in contact with the pipes. When resting on rock, the pipe shall be bedded on fine selected material, or especially where there is a steep gradient, on a layer of concrete. So again, bedding is important here. We do not want any bowing of the pipe, deflection of the pipe that may cause damage to the pipe or fittings themselves and cause leaks and failure. Item D gives us a requirement for the width of excavation trench shall be at least 0.4 meters more than the outside diameter of the pipe. So not only do we have bedding requirements, we also have width minimum of the trench based upon the outside diameter of the pipe. Item E gives us the depth of the ground cover, and this section indicates that it needs to be at least 0.9 meters under the roadway or 0.75 meters under garden from the top surface of the pipe to the ground surface. Item F, finally, the bottom of the trench shall be carefully prepared so that the pipe will be bedded well for its entire length on a firm surface. As indicated in the graphic below, we have a water supply pipe running to a building. Below the pipe, we have bedding for the entire length on a firm surface. This will be fine graded material, selected material, that is utilized to support the pipe. From that point, from the side, we're given the requirement of the minimum width of the trench. So on both sides, we need to be 0.4 meters more than the outside diameter of the pipe. That would be our minimum side distance measured from the pipe to the side wall of the trench on both sides of the trench. And finally, the minimum cover shown here above a garden, below a garden would be 0.75 meters would be our minimum cover from the garden surface to the top of the pipe. Section 5.16.6, Special Care for Rat Proofing. This gives us a section on requiring rat proofing. The location and installation of any water meter box needs to be sealed. It shall be such not to permit the entrance of rats into the building. The opening through walls, floors, or ceilings for the installation of piping shall be closed by using proper collars to prevent the entrance of rats. This section requires rat-proofing measures regarding all openings into buildings made by equipment and also piping. Rodents can enter a building through the annular space around piping that penetrates a wall, ceiling, or even a floor. These spaces must be blocked using caulking or gasketing of approved materials. The methods and the materials must provide an effective barrier that would restrict the passage of rats into a building. The picture shown off to the right indicates pipe openings into a building that are protected to prevent the entrance of rats. This is a packing material that's packed into the annular space and sealed with a durable waterproofing finish that is designed to prevent the entrance of rats into the building. This is so important because we want to keep the people safe and healthy within the buildings and keep rodents out of the building. Section 5.21 gives us requirements regarding inspection, testing, and a completion certificate. So piping and joints are not permitted to be enclosed. They're not permitted to be concealed or covered until they have been inspected and approved by the authority. All piping and fixtures shall be inspected for satisfactory supports and protection from damage and corrosion. So the authority must inspect all piping, all joints, all supports prior to any concealment or covering with earth. This is important so we can verify the materials have been used that are proper. The materials have been used that have been approved and that are in this code. The fittings have been made up according to proper installation standards, the correct size of pipes according to the construction documents is what we look for out in the field, and the bedding as well as the depth of the pipe accordingly. It's the responsibility of the permit holder or the agent to call for the required inspections before the work is concealed and to provide access to such work. In other words, if you have to climb down into a trench, you need to be very careful, such that the trench is laterally supported so that it will not cave in. If you have to go down, make sure that that's the case. Make sure the safety is of the importance here, and there is safe access to the location that you need to verify all of the piping accordingly. If your inspection reveals that the work does not comply with the code or what the authority has approved, the inspector notifies the permit holder or the agent of the deficiencies requiring correction. Upon replacing, making the deficiencies whole again, the inspector must approve the corrected portions of the work before they are concealed. In other words, the inspectors must come back and verify that corrections have been made before concealment of the piping. Section 5.21.2, testing. So after the installation of the entire water supply system, or any part, it shall be tested and approved by the authority before its use. This is so important. Item A gives us the method of testing of water mains. The section of the main to be tested shall be charged with water, carefully by providing a 25 millimeter inlet with a stopcock to expel all air from the main. The main shall be allowed to stand full of water for a few days. In other words, we are charging the entire main with water at a static pressure. The main shall be allowed to stand for a few days full of water. We observe at that point to see if there is any leaks in the system. After the mains have been set for a few days, then they need to be tested to a pressure of 500 kilopascals or double the maximum working pressure, whichever is greater, for at least 5 minutes. The system shall be able to maintain the above test pressure. So if you read this, you are looking for a two-part test here. The first part is testing of the mains. We have to charge them with water, let them last for a few days, just verifying no leakage under that static pressure. Second, after a few days without leakage, we must provide a pressure of 500 kilopascals or double the maximum working pressure. Apply that to the system for 5 minutes and observe if there is any leaks in any joints, parts of the piping, things of that. On the right-hand side, showing a 25 millimeter inlet with a stopcock to expel air from the main. We can also use that T as a mechanical pressure gauge attachment to verify our pressure in the second part of the test is not less than 500 kilopascals, and we would observe the pressure gauge accordingly for 5 minutes as indicated in item A of section 5.21.2 above. The completion certificate is indicated according to the requirement based upon section 5.21.3. The licensed plumber shall issue the completion certificate in a prescribed form. The reference here is Appendix N. The plumber needs to issue the completion certificate to the authority on completion of the water supply system or any part thereof for inspection and testing. After testing, the authority will allow the water connection from the water main and give the final approval to use the section or to use the system if it's a brand new water supply system. This section requires that the licensed plumber submit a completion certificate to the authority as a function of providing specific information, such as piping location, owner information, name of the applicant, as well as technical information regarding the piping system. And again, the reference to Appendix N is given in this section for the completion. Appendix N indicates format of completion certificate, water supply works. This is a completion form that is filled out by the licensed plumber and submitted to the authority when the work is done. And as indicated here, it states certified that I or we have completed the plumbing work of water connection, given a number, for the premises as detailed below. This may be inspected and connection given. Again, ward number, road number, house number. The plumber must state the location of the work that has been performed. The plumber must indicate the owner, the owner's address, the applicant's name, the address and location, where the main is, and the size of the service pipe, the size of the ferrule, any number of traps, any number of closets, the capacity of underground reservoir where required. Now this could be an underground water storage tank connection as well. So the capacity has to be known and has to be stated here. Under the capacity, number of other fittings and appliances, any road cutting and repairing fee is indicated here. So the signature of the licensed plumber is required, and the name and address of the licensed plumber is required. On the bottom portion of this completion certificate is the authority's report certificate, and it indicates the following. Certified that the communication and distribution pipes and all water fittings have been laid, applied, and executed in accordance with Chapter 5, Part 8 of the Bangladesh National Building Code, and satisfactory arrangements have been made for draining off wastewater. The water supply connection will be made on a predetermined date filled out by the authority and dated accordingly and indicated by the water supply authority. So this gives us a format and the form of a completion certificate that the plumbing licensed plumber will fill out upon completion and submit it to the authority for connection of the water supply system. Section 5.23, Individual Water Supply System. In the absence of a public water supply, the individual potable water source shall be used to supply water in a distribution system. The following water sources may be used for individual water supply purposes: either a drilled well, a dug well, driven well, spring, or an infiltration gallery. Section 5.23.5 gives us requirement for location of water source. The minimum distance of water source and pump suction line from potential sources of contamination shall be in accordance with Table 8.5.16. Remember, we do not want any source of contamination in the potable water supply system. That's why we have this section, and it refers to Table 8.5.16. The most important aspect of a plumbing code is the protection of the potable water system. History is filled with local and widespread occurrences of sickness and disease caused by not safeguarding the water supply. Again, this section contains the requirements for protecting the potable water supply from such contamination. The Table 8.5.16 gives us minimum distances from potential sources of contamination. As seen here, on the left-hand side is the potential source of contamination, such as pump floor drain of cast iron draining to the ground surface, sewers, farm silos, septic tanks, subsurface pit, seepage pits, subsurface disposal field, barnyards, and pastures. In the far column, there is a distance, a minimum distance that's indicated from the potential source of contamination to the water source and pump suction line. So this table contains the requirements, again, for minimum distances that must be maintained away from the location of the water source and any pump suction lines. As an example, if there is a local septic tank, the septic tank would have to be at least 8 meters away from any water source and any pump suction lines, according to the table. It's always acceptable to exceed the distances, but it can be no closer than what is given in the table accordingly. This is the end of the presentation. Thank you for participating.